So in this video, we are going to continue our series on building a development environment for a web application. In the first video in the series, we just introduced the project. So if you haven't seen that, maybe go back and see that first. In this video, we are going to adapt Docker. And at the end of the project, we're going to end up with something looking like this, where we have network separation between a reverse proxy and our application server, and our application server and the database. So they're each going to be connected to their own network. So let's get started. So let's look at the project directory. So we have a guestbook.py application. So our application, as I introduced in the first video, is a simple Flask-based Python application that we can send some HTTP requests to for viewing and storing and deleting entries in a guestbook. We also have an environment file for some environments variable that we are going to set. We have a provisioning script in the db files directory, and we have a gitignore file. So let us try to look at the application first. So the application makes use of the Flask framework, as I said, and we're also making use of something called a Postgres connection pool. That is an optimization for keeping the same connections between the application server and the Postgres database alive and being reused. It comes with another very nice feature, is that we don't have to put the configuration parameters into our Python program. Those can be set via environment variables that the psycopg pool package will automatically read. So it helps to keep a lot of clutter out of our Python file also. So that is a good thing. Our guestbook implements these three endpoints. So there's a root endpoint here that receives GET requests, and it will simply do a select all from book and display the content. And the content is going to be plain text. We're not going to bother with templates and HTML in the first iteration of the project here, because it doesn't really matter. So let's just keep things simple. We have an endpoint also on the root address here that we can send post messages to, and these will simply be inserted into our database. Finally, we have a delete endpoint that takes a guestbook entry ID in the path, and it will simply delete the guestbook entry from the database. As you can see here, we are setting up a web host variable. This is by default going to be 127.0.0.1, so the local host address. And by setting an environment variable to web host, or rather the web host environment variable to another IP address, we can make this application behave in a different way. We're not going to need this at the moment, but later we will. Likewise, we can set the port here. It will be running on port 3000 by default. And we're also going to print out the host configuration just so that it will be easier to troubleshoot if that is necessary. And finally, we start the web host here. And the provisioning script is a simple SQL file. It will create a table with an ID that is a serial primary key, a TS timestamp that will be set automatically to the current time, TX, which is a text field that will allow us to set some message in the guestbook, and finally a host field that we will later use to set the name of the host or rather the application host that is handling the entry. We have an environment file here that will contain the parameters for the Postgres database. We are going to use a Postgres Docker container for running the database right from the beginning, and the Postgres image will expect to see these variables set and configure itself based on that. So those are needed for that. The other environment variables down here are the ones that are going to be read by the connection pool for CycopG. So these also needs to be specified here. We're not using this RTE variable at the moment, but that will be in use later. And the gitignore file, we are ignoring SWP and SWO files. This is because I'm using the Vim IDE, and these swap files will turn up in our directory once in a while, once we have the files open, and we don't want them to end up in our Git repository, so we add them to the ignore file here. PYC files and PyCache files are temporary Python files that we also don't want to end up in the Git repository. .dsstore is the file that macOS use to save thumbnail images if you open a directory in the macOS Finder. We also don't want that in our Git repository. The .venv is a directory that will store our Python virtual environment, which we will install packages into. And finally, the tags file, because I'm using C tags with my Vim configuration, there will be a tags file in my directory. And again, it's not something we want in the Git repository. So with that, we can begin building our environment. And the first thing we are going to do here is to create a Python environment file. We are going to use the UV tool for handling our dependencies. And when we run the UV init, we are going to see that we have a PyProject TOML file added to our project. And if we take a quick look at that, we can just see that it specifies our Python version and an empty list of dependencies. So far, so good. We will then install our dependencies into this Python environment using UV-add. And this is, of course, the Flask framework and the various CycopG files and packages, and then whatever packages are needed by those other packages. So far, so good. Let's just check what Docker version we are running, because in order to follow this project, you need to have Docker installed in a reasonably new version. So if you have something similar to this, that should be just fine. We are going to run a Postgres database, as I said earlier. And this is the command that we are going to use for that. So let's just go through the options here very quickly. So the --rm switch is for automatically removing the container once it exits. So we're not going to end up with a list of old containers. We are setting the name Postgres for the container. We're using the environment file envlocal that we just looked at before. So the Postgres configuration will be available to the container. And we are mapping the 5432 port on 127.0.0.1 so that we can reach the database from the host network. We're also making a bind mount with the -v option that points to the DB files directory with the provisioning script that we saw earlier. And finally, Postgres is the name of the image we are running. So running that, we get a database and it's ready to accept connections. So far, so good. This database needs to keep on running. So I will open another another window here in Tmux and continue from here. So at present, our Postgres database doesn't have a schema. So that's the first thing we are going to take care of. So we're going to exec into the Postgres container and have a standard shell there. And we can see here our prompt changed to a hash sign, and that is the indication that we are now inside the Docker container. And here we can run the PSQL tool for managing the Postgres database. So far so good. We need to run the provisioning script, and we can do that with the \i command. And doing that, we can see here it returns create table. And if we now take a look at the schema, we can see that the book table has been set up in our database schema. We can exit out of Postgres here, and we are back to our prompt. And with that, we can run our Python application. Again, we point the UV tool to include the env local environment file, so the variables set in that file will be available to the application inside the Docker container. That's a very nice feature with UV, that you can specify the environment file this way. So running that, we can see that our server is listening on 127.0.0.1 port 3000, just as expected. And again, we need to leave this running, so I will open up yet another window in Tmux. And here I can try to issue a post request. This post request is going to set the TX and host fields on the database, or rather it's going to send it as an HTTP message, obviously, but our application is going to insert these fields. So we're sending this to 127.0.0.1 port 3000, as we saw our application server is running on. So issuing this command, we can see that we get a response with ID 1, our message, a timestamp, and the host name that we configured in the message. So we can also access the root path with the GET request, and we can see that we get the expected message. Our message has been stored on the database. And with that, we can change our focus to adopting Docker. So I'm going to bring in a few files here. You will not be able to run this command if you follow along from home, but you can go to the website engenie.online and see all the source files available there. So the Dockerfile, let's just take a quick look at that. So I'll open it here. So our Dockerfile is very simple. We are running on a image based on Alpine 3.22 with a Python 3.14.3 environment. So that's the base image for our Docker image. We're setting an environment variable, Python unbuffered equals 1. And this is a very strange thing when you are running a Python project. If you don't set this variable, whatever you write to standard output and standard error will not be shown in the Docker log, which is very annoying if you are looking for messages there for troubleshooting. So it's very important setting this variable. We're going to install the UV tool using our APK package manager on Alpine Linux, setting the work directory to /app, copying the project.toml and UV log files into the app directory, and I can see there is a small error. That dot should not be there. This is necessary in order for us to run the next command here, uvsync, which will take our package list and install it into a virtual environment within the Docker container. The next thing we are going to do then is to copy our project directory, or the rest of the project directory, into the Docker image. And we're actually not going to need all the files. And again, I have an error here. Sorry about that. We're not going to need all the files, but we're going to address that with a Docker ignore file later on. And you might wonder why we have 2 copy statements, why we are not simply doing all the copying like this in line 11 here first time and then run UV sync afterwards. But the issue is that our dependency list is going to change far less frequently than our source files. And splitting this means that Docker is going to create 2 separate layers, one for the dependencies and one for our source files. And the dependency layer will then be able to be reused until dependencies actually change, which is, as I said, far less frequent than our source files when we develop our project. So this is an optimization issue. There are, of course, lots of things that we could optimize here, but in the spirit of keeping things simple, we will leave it at this to begin with. Finally, our entry point. So our entry point is, what is the Docker container going to run when it starts up? And in our case, we're going to run a shell script called entrypoint.sh, and that will take care of opening up our web application. So the next thing we need to bring in is the entry point script here. So let's go back to Vim and take a look at that. So I need to save that first. Entry point, like that. Our entry point script is very simple. It has a shebang here for setting the shell, outputting a simple message, and this is for us to be able to see in the log that our entry point has actually started. That is very nice when we are working with Docker, that we include some messages as execution progresses, so that we actually know what's going on when we are looking at the log. We're using exec here to run the UV tool and start our guestbook. And the reason we're doing this is that if we don't put exec here, but rather just say UV run guestbook.py, sending a command C signal to the Docker container will actually not shut down the guestbook application. And that is because using exec, we are actually replacing the process that is started up by this entry point script, rather than making a sub process. And if we exclude exec here, we will run in a sub process, and the parent process will receive the control C signal and not stop our application. So that is not ideal, and this is why we're using exec here. Our Docker ignore file, let's just look at that here. Very similar to our git ignore file, only we are also excluding our Dockerfile because we don't need that in our image. So far so good. With that, we are actually ready to try to build our image. So let's do that. So we are building our image and tagging it guestbook:/latest, and it will find the Dockerfile in current directory. That is what the dot at the end indicates. So that built successfully. And with that, let's try to take a look at our list of Docker images here. So we can see it's listed as the second one from the top here. So that's all good, and we can now try to run it. As you can see, this is kind of a mouthful of a command. So we are running it again with the --rm option to automatically remove it from the container list after it exits. We are naming it guestbook, we are using the host network. This is not ideal, but it is just to make things run for now. We are going to get away, we're going to set up separate networking in the next video. But for now, simply running things on the host network is the easiest option. Again, we're using our environment file, and we have to make a small change here, like that. And we are running on port 3000 on the host network localhost. So let's try issue this command here. We can see that our entry point script started and something is wrong. Yeah, so there's a problem here, and obviously we forgot to shut down the application running in the foreground here. So with that, let's try again. Yeah, so now it's listening on port 3000, and we can now go back here and try to issue a command to see if we can retrieve the content from the database, and that works fine. So so far so good. We have managed to take our Python web application and package it into a Dockerfile. It's quite obvious that this is not an ideal way of running our project, because we have to provide all these parameters each and every time that we are running the project. This is both error prone and very cumbersome. So in the next video, we are going to set up a Docker Compose file that will encapsulate all these configurations, so that we can simply issue a very simple command to take up the whole project and make sure that there are no errors when we do it. So that will be in the next video. But for now, that's it. If you like this video, please like and subscribe, so I'll be encouraged to make more videos. But that's it for now, so see you in the next video.